I'm delighted to introduce Alison from Parsons, who's going to talk about the design and manufacture of test coupons for risk reduction studies of printed hybrid electronic assemblies. As always, please leave some questions for Alison on the speaker bar on the right-hand side. And after her presentation, I'll come back and we'll take your questions. Over to you, Alison.
All right, thank you, Chris, and thanks everyone for joining me today. As Chris just said, my name is Alison Kritz, and I'm a materials engineer at Parsons, currently focusing on our printed electronics initiative. And today I'm going to be presenting on a risk reduction study that we've been working on for one of our current printed hybrid electronics projects. So I'll start off first by sharing an overview of the prototype PHE assembly that we've been working to build. Then next, I'll discuss some of the potential concerns that we have with our current design and the reasoning behind those concerns. Then next, I'll get into the details of 3 test coupons that we've fabricated to address these concerns, including their design, test methods, and results. Then finally, I'll end with some of the conclusions that we can draw from this risk reduction study and our plans moving forward with the project. So this project is focused around a prototype PHE Arduino type circuit. So this assembly would integrate various active and passive components with the features fabricated through several additive manufacturing technologies. And these include stereolithography, syringe, and aerosol jet printing, with our main focus being on aerosol jet printing. So to fabricate these assemblies, we would start by first SLA printing the substrates using Formlab's high temp resin. And this is to make sure it can withstand the high temperature processing methods that are needed. The substrates are designed with these precise geometries, as you can see here. And we found that SLA printing is ideal for this because it has these high resolution capabilities. So the next step in fabricating the substrates is to smooth them down, just to remove any printing supports and give them a nice flat surface to work with. So then once we have our substrates, the next step is to place the components. So we have a couple different types of components here that are placed with both manual and automatic methods, like pick and place technology. So in the center here, we have the die of an Atmega 328 attached directly to the substrate. And up at the top, we have a voltage regulator and an accelerometer placed in these larger cavities, as well as several passive components placed in the smaller cavities. Then we also have these gold contact points that we use for testing and programming. So along with placing the components in this step, we also encapsulate them in the cavities using a controlled volume fill syringe print. And this allows us to print directly to the pads of the components for this next step. So then finally here, we deposit the circuitization and dielectric layers of the circuit using aerosol jet printing. So with this, we're able to precisely control the deposition rate and subsequently the height of each of the traces using the inkwell method. So now stepping back a little bit, the overarching goal of this project is to fully qualify our PHE production process. And to do this, we chose the Arduino type circuit I just described as just a demonstrator. So using this fabrication method, we've successfully produced one complete prototype that we have almost 100% functional. However, we do have some concerns about the reliability of some of the elements of component integration and different material interfaces that could possibly result in early failure of the assemblies. So before we begin production on the full qualification lot, we decided to take on this risk reduction study to separate out certain high-risk areas and test the reliability of each of those individually. So the way we did this was through 3 different test coupons that were designed and then tested through temperature cycling. So now getting into the concerns that we have with this assembly, our first main concern is with the thermal expansion mismatch between different materials in contact. So this basically means that for our chosen material set, the materials will expand different amounts when they're exposed to heat, for instance, through curing or through reliability temperature cycling. And this can result